Welcome back. Willkommen zurück.
Es geht heiter weiter.
The next team also has 2 international students, so this presentation will also be in English.
Have you ever talked to an intelligent being? Something like this?
No. But now that I think about it, how would it answer?
The next team gives you the opportunity to experience human-machine interaction firsthand.
Ladies and gentlemen,
Team ARI.
Okay. The desire to have robot companions is no new phenomenon. Even in the 1950s and 1960s, people found the idea of living and working with robots fascinating. But where do we find robots and industrial robot arms nowadays, for the most part? They mostly sit in factories, in cages, and perform monotonous tasks, and are generally very far away from humans. But recent efforts are made to make robots more accessible to humans and bring them closer. And the question that arises here, if we want to work together in the future, is how can we communicate with intelligent robot arms?
So, how does that communication look like right now? As of now, we mostly interface with robots through screens that allow us to actually program them, like mostly with hard-coded movements. So, you're pretty much always required to have intimate knowledge of a programming language and even get a degree in software development. Because if you don't, there's not... and... Excuse me. The thing is that the thing we looked at was just how could we make communication with these robots more accessible to people who couldn't just get around to getting a software development degree. So we looked at different modes of communication that we thought we might be able to employ with robots that weren't exactly humanoid in nature. So, sorry. So what we did is we looked at body language as an option. It works for the most part across different species. If a cat is afraid, you can tell that the cat is afraid. And it works somewhat across cultures, but even if there's differences, there's still a lot of commonalities that we can make use of. So we looked a lot into how different modes of body language would work, and then we thought about how we could translate that to an industrial robot arm. So the thing we started with is an incredibly low-tech version of a robot arm.
As you can see, we had all this research about body language and wanted to know if it would be a good way for robot arms to communicate, but we had no easy way of testing it. So we replaced the robot with a sock and pretended that this sock was the robot, and from this made our movement concept for the robot. Now the task was to transfer the things that we learned and the movement concept we came up onto the actual robot, which is a Franka Emika Panda model, which doesn't need a cage around it and can be touched by humans, can be worked with in close proximity with humans. And yeah, so let me give you an overview of the control scheme for the robot. The first way to actually operated is with the interface that comes delivered with the robot, which is called Pilot. Here you can get a linear sequence of different motions, as you can see the different colored icons, and in that way program a very complex and linear movement. You can then save this movement and replay it later. But of course, this is not very reactive. So we have another way to control the robot, which is a program made by Elias Napphausen with the library ROS for robot programming. And it enables us to control the robot in real time. As you can see, you can move it along its axis and rotate it around that point. If you compare these two movements, you can see the point that I made previously about precision and reactability. Maybe if you come visit our booth later, you can even find out the difference yourself.
So now that you know how we made the robot move, what do we actually do with it? Talking is difficult. What we put up here today is sort of an interactive installation where you as a visitor get to interact with this industrial-grade robot. This is our essential setup. Most of you will walk past it already. We put up the robot in front of a portable wall that we made, and the operator of the robot is behind this wall. From there, they can see what the robot would sense and see and hear through a camera and a microphone. And that data is fed back to the operator behind the wall so they can move the robot accordingly.
Yeah. But what if we go one step further? What if we look into the future and explore how it could look like if machine intelligence awakens at some time? The following film explores this idea, and for all of you who's been wondering what ARI actually stands for, it stands for Autonomous Robot Intelligence, and you're about to meet her. You might have noticed that was the team at the end.
Was it really? So now that you've seen our masterfully crafted film for a backstory, if we actually want to work towards this future that past generations have already dreamed of, the thing we learned we had to do was work on accessibility of these technologies. Just because if you don't make them accessible to everybody, you can never really get them implemented in everyday life. Because as opposed to, you sit in your car and your car works. That's one thing. But if you want an actual robot to interact with you and to interact with, you're gonna need to understand how you can communicate with it instead of just plainly telling it to follow a series of hard-coded movements. This mic keeps annoying me, sorry. But the thing we mostly took away from this is that the technology is still in its fledgling stages. There's no fully incorporated AI yet, there's no such thing yet. We don't have the technology yet. But if we don't start from the bottom up to work with it, to make it accessible to everybody and not just a few select people, we can't actually make this idea of everyday interaction with them come true. So if you want to take a look at how that interaction might look like, our booth is still up. Thank you.